Okay, so the session is now being recorded. And we'll start in 2 minutes' time at it's 11:15 here, and that'll be 6:15 at Beijing. So again, I'd like to apologise due to the coronavirus situation. We can't be present in Beijing to interact with you face to face, but we're trying to do our best to do it online instead. So that's why we're doing it this way. Hope it comes out okay. Okay, so thanks everyone. So yes, so this is the final session, the tutorial session for week 4, and what I'm just going to do in this 1-hour session is just to go quickly through everything that was provided for week 4, just briefly going through it, just to try to give a general explanation, a summary of what was done. So I want to share the screen. So most of the time we'll be sharing the screen. It's just so what I want. Okay, so yes, that's sharing the screen for week 4. So that's what I want to cover now. Okay, so teaching week 4. So teaching week 4 had 3 separate sections: design patterns, open source software, and practice. I think design patterns probably the longest and most complex one on aspects of code. But then open source software is also very important, and we just finished with tools and best practice. As well as that, well, after class reading, we had these are links to material produced by other people, which I thought might be useful to as additional reading particularly on design patterns. The actual code that was used to illustrate design patterns is all given here as well, the actual code, and that will help to actually download and run it yourself. It's a good way to learn, but also a very good way to learn is to write your own code. So we are giving some actual exercises here for writing code on design patterns. I'll go through these. Well, I'll go through these a little bit later. Okay, and written explanation. So written explanation exercises. These are about the exam questions where you ask to write a written explanation of design principles and design patterns. So explanation in English, you can illustrate them by giving code examples, but the explanation does need to be written in English first. And what we're doing here is giving the exam questions and then some very detailed answers. So initially, exam questions are given, and then I've now given them solutions as well. Okay, so the solutions have been made available. Now, also on these written explanation exercises, video 33 and 34, and those were done by Gokop, and he is going through the answers, explaining them in detail in a lengthy lecture. So do look at those lectures as well. It's going through answers to actual questions from past exams. Okay, so then let's go back to, as I said, I'll just run briefly through the slides of these, just to try and give a general explanation of what they're all about. Of course, the lectures on them you need to look at, and for yourself, look at the slides, read them in more detail to get a good understanding of them. So design patterns is really following on from design principles, which we did in week 3. Let's just go back to week 3. Project management and design principles. So design principles is important rules for good structured code. So that's the most important, most basic thing of good structured code is that it should be divided into separate parts, where the way that the two separate parts interact with each other is limited. And that's good, because if the limited interaction between different bits of code interaction is limited, it's easier to understand how the code works if it's very clear which part does what, and it's easy to make changes to it if you know that there's only one part you need to change. And also, the other good important aspect of design principles is to try to avoid repeated code. Instead, to see if you can write one piece of code that could be used in several different places. So writing generalized code is a way of doing that. And that's another very important way. It reduces the overall size of the code, which is good. And also, it means if you want to make a change to that piece of code, you just one place, rather than lots of different places. So that's all aspects of good quality coding. So design patterns are really about ways of doing that, ways of structuring code. And particularly design patterns, it's perhaps ways that you might not think when you first learned to program. It's ways that perhaps skilled programmers have got to use. It's sort of techniques used to produce code. Okay, so I'm going to go through the slides of design patterns very quickly, because I can't go through in detail in just a 1-hour tutorial, but just to try and summarize what those slides are about, and then I'll go through the other ones as well. Okay, design patterns. Okay, software engineering design patterns. And it starts off with an example. Okay, so this is using the code. I mean, those actual code is available, the duck and the duck call. Okay, so what we're doing here is we're saying, well, the example given here is, suppose we're passing in a crackable object to some other code. I mean, it could be any other code, and we want to count how many times is a method crack called in that code. How could we do that? Okay, well, what you would probably think of at first is just change the code to do that count. Okay, but in a large piece of realistic code, a real program, you can't just change code like that, because the code could be used elsewhere. You can't just change it. So how do you do it without changing the existing code? That also meets the open code principle. Open code principle. Okay, so how could we do that? And this is where we use a wrapper. So a wrapper means an object inside another object, and when you call a method on the outside of the wrapper, it calls a method on the inside to perform a task. So we do some additional task, and that's what the decorator does. What a decorator does, it inputs the same interface. It works by calling the same method on the wrapped class, wrapped object, the object inside, but does some extra work as well. And the extra work here, which is a very simple example, is to count the number of calls. Okay. The solution is crack count is the wrapper. Counts the number of calls, and here's just the code giving it. Okay, so quack count implements crackable, which is the interface. When quack is called on the quack counter object, it calls quack on the crackable object inside, also increases the count. So what that means is that this variable count will count the number of calls of quack, and an additional method get count, which returns a value of that. So this is a very, very simple example of a more general idea of a decorated design pattern, and that means an object which calls the same method on an object of the same interface inside, but does some extra work, it would return the same value if it was returned, although the return type here is void. Point to understand is just, for example, just a very simple example of the more general idea of a decorated design pattern, which can be anything where we're working in a way which adds something to what a method does. It's doing it in a different way of inheritance. So you could do it by inheritance, but this is a more general way of doing it. Okay, so just an example of decorated design pattern. So I'm going to have to go through it very quickly in order to go through everything in 1 hour. So go for it. So wrapper design pattern. Example, the general sort of wrapper design pattern where, as I said, when an inner object is inside the wrapper. So another example is the adapter design pattern, and this is the adapter design pattern. Let's go to that. Is where we're adapting a class. So objects of that class can be elsewhere. So the class itself does not implement an interface. Maybe it's a class that was previously written, doesn't implement the particular interface, but it works a similar way. So the way we can enable it to implement the interface is have a wrapper which calls, when the method from the interface is called on the wrapper, the equivalent method is called on the object inside it, which is being wrapped to do the task. Okay. Again, you might say, well, why not just change it? And that's because it's existing code. You can't just change existing code; it can be used elsewhere. Again, a very simple example. So what we want here, we've got a class goose which has a method honk, which is similar to quack. We say, well, how can we make goose work? So that code which takes a quack object, anything with quack, could also take a goose and call honk where quack is asked for. And this is how we would do it. Goose adapter adapts the goose so that it implements quackable. And how it works. Goose adapter is a constructor, has a goose inside it. Quack's called on the goose adapter, and honk is called on the goose inside it. So that's converting call a quack to honk. Okay, so why not just change the code? Other code could already make use of it. In the more general, you can't just change the code. But also, it's separating with tasks. So we're saying it's separating with different tasks, and that meets the single responsibility principle. Using the wrapper for it. But also another issue here is that we might want to pass full access to goose object. Perhaps we do want to pass it just as the interface. So rather than passing full access, just passing as an interface means only the methods from interface can be used. So limiting the amount of interaction between code is also a very important way of well structuring code. So it could be done by inheritance. That means that you are passing the whole thing through, because a quacking goose inheriting it. Okay, we're giving it a method quack, but a quacking goose also has all the methods from goose. So we give a very simple example. In reality, it could be much more complex code with many more things in. And the other thing, of course, is that the wrapper could wrap existing object, whereas the inheritance is only going to be able to have a new object which implements quack. Okay. So these were just two, the adapter and the decorator, two distinct examples of a general idea of a design pattern. And there's many more established design patterns, and we're going to go through more of them. We're only going through some design patterns. A design pattern is just a general way of constructing code to form a particular sort of task. Okay. And there are many sorts of design patterns. We do go through in this whole section of design patterns, just the most important design patterns, ones that are most generally used. Design patterns are provided with a vocabulary. Okay, so a vocabulary is words we can use to describe the way we're structuring code. So if we know those words, it can help us talk with other programmers about exactly how our code is structured. That's also very useful. Composite design pattern. Another form of a wrapper, but in this case, what's inside that wrapper is not one object, but a collection of objects. And it's a way of converting a collection of objects so it can be used as if it were a single object of that type. Simple way of doing it just to call the same method on every object in the collection. But it could be other ways that it could work. We're choosing one of the objects to do it. So that's the composite design pattern. The mutual review design pattern, another very important form of a wrapper design pattern. Remember what a mutual review means. What it means is if you want to pass a reference to an object over to some other code, but you want that other code to be able to use the object but not make changes to it. Okay, and that's very important as well, because you may want some other code not to make changes to because it could cause problems. And how can you do that? And you do it by creating a mutable review, and that's a wrapper which works in a way that if you call a method on the wrapper, the same method is called on the wrapper beside it, but only if it's a method which doesn't change it. If it's a method which changes it, instead of calling the method, it just throws an exception. So that's a way of passing a reference to an object, some other code, where the other code could access it, we can't change it. I'll give a simple example here. So the simple example uses the rectangle class, which we gave as an example of code in week 3. So rectangle, remember, has a variable width and height inside it, and it has getters and setters of width. So setters would be a way of changing the rectangle, or changing the width, or changing the height. Also, as a method area, which represents the area of the rectangle. Okay, so how this works is the rectangle is inside it. The constructor puts the rectangle inside it. We pass the rectangle object. It's like passing the rectangle inside it, because if we'll get width on it, we'll get width on it and return what's inside it and get height and area. But if you call set, which would change it, instead of doing anything, it just throws an exception. So this is just a very basic example of a more general idea of how to create an immutable view of an object. So the next design pattern that we cover is the observer pattern. Okay, observer pattern is a way of structuring code. Okay, so what we've got here is the idea of an object which is doing something, and we want other objects to interact with other objects when it does something. And the particular reason for doing that would be, suppose we've got some an input-output graphical user interface used by some code, and we want to inform the human user of code what's happening. But it's important to have a clear separation between those two parts of code which represents objects, and code which deals with the interaction with human user, and limit the interaction between them. That's what the observer pattern would do. Again, that's what we mean by the model view controller. Clear separation of code. So the most basic way in which code should be designed is a clear interaction between the model aspects and the view aspects, with the controller being the link between them. Also called boundary control entity. So in week 2, that's the word used for it. So a boundary class is a class which is dealing with the human user. So the graphical user interface would be providing the graphical things on the computer. Well, the entity represents the objects, the actual objects in the data which have been modeled by the code. The controller is the link between them. Okay, so to illustrate this, I'm introducing another class called dogbot. This represents so sort of like a dog, like a robot dog, like a toy dog as a robot. And again, we'll try to keep it simple. So dogbot has Hungarian tile inside it and a name. The important aspect of object programming is you shouldn't be able to access directly inside it, and this is a particular reason for doing so. Rather, they're changed by the method calls on it. So the method on a dogbot is rest and the play, which change Hungary and hard, and eat, which will change for hungry. It may eat or may decide not to eat, and also noise just returns a noise. Okay, so the point here is how could we implement a dogbot object so that change that is indicated to some other code which has something to do with a change. Maybe it prints something or says that something has been changed. So Java provides some simple code which can do that, and it's the observers pattern. Object class observable. So to talk about implement observable, it would well, it's implemented extends, so it's a subclass. So it actually has these objects, these methods here, which create a list of observers, which can be changed. And notify observers, when notify is called, that sends what that does is that the method update is called all the observers and set changes so when it's changed. So that's the way of interacting, but limiting the way that code can be interact. That's the important thing. And so it makes code simpler if the interaction is limited in that way. Clear division between the model view controller. So here's how it could be done. Class is before, but we put notify observer here when the dogbot changes. And notify the method called notify observer here just passes the string which the name of the thing that took place that caused the what's inside to get changed. So when notify observer is called inside a dogbot, inside the an observer object. So observer is an interface, and we must implement update which does something. The update is called it. In this case, so what happens here is whatever's passed here comes the actual object here, and the observable is the actual object, the dogbot in this case, which is passed. Because generalized, it isn't an issue of dogbot. We can cast it in order to treat it as a dogbot, and then action could be anything, but in this case it's a string. So if we just do plus action, it will automatically print the string. So in this case, the observer just prints the name of the dog and the action. So also what we're doing here, the information, we call this pushing and pulling. The information that's pushed is the name of the value of the object that's passed. The information that's pulled is the additional information which was obtained by calling a method on it. So it's the name of the dog which is pulled. That's pushing and pulling in the observer design pattern. Okay, here's just an example of making use of it. Just saying that the observer is a subclass, as an actual class which is inherited from. Broken the open close principle here because we actually had to change dogbot to do it. But what I'm saying here, we could also instead do it using a decorator design pattern with a wrapper to do that. And here's an example of that. So observable dogbot is a wrapper which performs the same thing. Okay, so what it's actually doing here is, remember how a decorator works. When you call a method from a decorator, it calls the same method of an object inside it, but there's some additional things. In this case, the additional thing that it does is the observable aspects, called them set changed and then notify observer. Get name and noise, don't change it, so it just directly calls the method on the object inside and returns what it returns. Just to say here, it would be better if dogbot made an interface type, because then it has to observable dogbot would implement the interface and then a general interface to represent all forms of dogbot. Okay. So we did mention this in general idea of design principles to use always use interfaces. That's a defender inversion principle for general code. So the only time that you use the actual class itself, constructor to create the new object of that class, but in general code, which interacts with other code, does it through a variable interface type rather than a variable of the actual class type. So now class observable dogbot implements dogbot, which means it could be used any place where a dogbot object could be used. So using this technique, the decorator to do it, separates the model from the view. Actual dogbot object, so separate from a dogbot object, could give a record of what it observes. So the simple example we gave was it just prints something. It could instead write to a file, display interface, or could keep a counter of actions. So this is actually another way using an observer doing the counting, which we saw previously in the simple decorate example. Okay, so here's it storing. This is an example of an observer which stores it, okay, rather than just prints it. So must have a method report, which will return it later to be printed. Example of it being used. And here's a counter. So what I'm doing here, just showing various simple examples of a general idea of the observer. So the observer is doing is counting the number of calls. And again, here's an example of it being used. So I suggest that one thing you can do, well, the codes will provide to that, you can actually download this code and run it yourself just to get a good feel of how it actually works and modify it yourself to just experiment with using it. Okay. Now I'm going to move on now, subclass. I'm just giving a very simple example of a subclass of dogbot. Well, we know that plain dogbot is a class which implements the so there's a dogbot interface, and plain dogbot is the simplest implementation of an interface. So greedy dogbot just changes it very slightly, it just changes the method each. Okay, I'm just giving an example of code which makes use of subclasses in order to describe factory methods. Okay, so a factory method is a method which creates a new object. Okay, say it's like a constructor. Constructor is new, the name of a class of the object and creates it. But a factory method is just now a factory method is actually going to call a construction side. The reason for using a factory method rather than just a constructor call is it's more generalized. And here's a simple example here. The method make dogbot has return type dogbot. It could return a greedy dogbot or plain dogbot depending on the value of this the parameter greedy passed on. So it's important because a constructor can only create an object of its actual type. So this must create an object whose actual is greedy dogbot. This must create an object whose actual is plain dogbot. But we can generalize the code now where in the way we're creating a new object, but the actual class of the object created depends on some of the information passed. So this is a very simple example, a more general idea of why factory method might be used. Okay, so factory methods almost look like constructors and objects. Usable to show the actual type of the object at runtime, can even hide the actual value of a new object. So it may be that it may return it what the actual object returns a subclass, but that's not actually given by the actual external code. So another reason for using a factory method might be to return an object which is already wrapped. I won't go through details of this example. It's another example of a decorator, so wrapper. Okay. So the next thing about factory design pattern is factory objects. So previous examples of factory method were static methods. So they're not called an object. A factory object is an object where if the factory method is not static, it's called on an object. So it's important to understand that a factory object is an object where you call the factory method on it to return. It's an object which works to create object. Remember, I find a lot of people think the factory is the object which is created by a factory method. No, it's the object which does the creation. Okay, so this is because there may be various reasons why we want to have a separate object to do the creation rather than just use static methods. Another way that enables us to write generalized code because we attach object onto other code, so different factory objects would work in different ways. Another reason for using a factory object is that the factory object may store some values in it, some data in it, which are used as part of the construction of a new object. And here's a very simple example. Remember that the constructor for a dog object has to take a value of the hungry and tired. But this enables us to have a factory method which creates a dog object just by the name, because the hungry and tired values used for constructor now are stored in the plain dog factory object. So it stores the data used to create it. And that's just perhaps a more convenient way of need to code where you can now create a dog object just by passing a name. So what this means is a factory here, plain dog factory, means every dog created will have an initial hungry and tired value of 4 and 2, but the call of the factory method created doesn't need to give a hungry and tired value. It needs to code. And I won't go through this. It's another example of in this case, it's creating a dog object which is wrapped and preserved. So this is using several design patterns now to give an example of constructing code. Okay, single design pattern. Another well-known design pattern. Single design pattern is again a form of factory method, and in this case, the code factory method which returns a new object actually doesn't return an object; it always returns the same object. So that's another reason for using factory methods, because in some cases where you write code which creates an object, actually rather than really creating a new object, you can return an object previously an existing object. And the basic design is a single design pattern. This is where it's decided that there must only be one object of a particular class. And how that's done is the constructor for the object is private, if that was the case. And the factory object which returns it. So what happens here is a new dog object, the make dog object always returns a reference to a single plain dog object. And that would be a way to say there's only one plain dog object. But this is a simple example, a more general example where we want to make sure that there's only one object ever return a particular class, which all code shares. Just a single example using Raptor, so that the single dog object has apparently different names. I won't go through details about it. More example of that initial substitution which we're given here. I won't go through details about that. Okay, the object pool design pattern. This is another example of factory methods, and the point here is that we have a case where when we create new objects, we return a new object if necessary, but if an existing object meets what's required, we can return the existing object was created previously. So what's happening here is when we create an object, we keep a collection previously created. In some cases, we return one of those rather than creating new objects. And one case that can be done, a simple case, was immutable, because immutable objects can be safely shared. Because they can't be changed, it doesn't matter that different code shares them. So in this case, we'll create a color object. If we've created an exactly color object with the same values previously, there's no point in creating a new one. We might as well return a reference to a previous created one, and that will save us the use of memory by doing that. So that's a good reason for doing it. It's just saving use of memory by creating a shared object rather than always returning a new object. So another reason for using the factory method is enabling us to avoid creating unnecessarily objects identical to the previous one if they're mutable, so they can be safely shared. Okay, so moving on to another design pattern, strategy design pattern. Strategy pattern is just really all it is a way of generalizing code. It's when we pass in a separate object which performs part of the actions of that, and that's all that a strategy design pattern really means. Separating code by passing a separate object whose role is to perform part of the actions of a general code. So, simple examples here. Quick fun. Actually, Java now has some additional ways of passing functions. We haven't covered those, so I won't go for that. Okay, so just don't go into detail. So one of the most common cases of strategy design patterns is the use of a comparator object. So what a comparator object does is it takes two of a particular type and compares them in terms of integer. 0 if they're considered equal, negative if object 1 is less than object 2, positive object 1 is considered greater than object 2, in different ways of ordering them. That's the reason it could be used, because objects could be ordered in different ways. Okay. So this is how we could use, and the clear example is using sorting. We can sort a collection of objects in different ways. The collection of strings could be, if you just use standard compare to on strings, it sorts them in alphabetical order. But if you pass in a comparator, which compares them in order of their length, it will sort the strings in order of their length rather than alphabetical order. So that's a simple example, really, of the general idea of a strategy design pattern is sorting by passing a comparator in comparison. Here's an example of a length comparer. Okay, so his collections has two forms of sort. One which sorts using the comparative method on objects, another which sorts using a separate comparator to do the sorting. Okay, move on to a state design pattern. I'm going to go fairly quickly for the rest of this because I want to also go through some of the not just the design pattern lecture, but also the other one. So design pattern is we want to change the way to. So what it is that the representation of an object internally can be changed in different ways, and that was the example given here. I think I will just go through it in detail. So what we're saying is that a representation of a set of integers could be by array of booleans if it's a small set. When it becomes big, you want to change that to another way, and that's what the state design pattern does. The design pattern just takes a little bit further inheritance. I won't go through detail on that at all, so that's all there is. Flyweight pattern is where an object has some aspects of it as shared, and therefore it uses what we saw previously to share the aspects of it. Okay, so this is just a summary of design pattern issues. Point about design patterns is tricks experienced programmers have come to use after years of experience of programming to really understand and make use of them. They're particularly in programming language, but they tend to use object-oriented aspects. So learning about the design patterns understanding is a way of becoming quickly someone who has experience, a more experienced programmer. Because they're not. When you first learn about how to program, you probably wouldn't think of doing these techniques. Ways of structure meet design principles, which we did in week 3. And that goes through in detail here. So depends also vocabulary. So what this says here is that once we've got the design patterns, we'll discuss with other programmers how we're structuring code. We can use those words for the design patterns, discuss it. That makes it much easier to really cover about how we have designed the code. To be cautious, don't overdo it. Design patterns. Okay, well that's cover design patterns. Let's go back to the next section. Okay, open source software. So again, I'm going to go very quickly through the open source software slides. Of course, there's a longer lecture on it. Okay, so what's open source software? Well, it also covers free software. Free software is actually, in some ways, a sort of even more general way of rights. Free software is software which is not just open source, but also available for anyone to use and change, and available for free. Okay, so the reason is just that the software is provided in terms of a human programming language rather than machine code. So traditional programming, all you will get is machine code to use it, which you can't really, because it's hard to understand how a machine code, you couldn't really change it easily. Whereas the open source software, you have the actual human code to look at how the actual software works. Okay, so why would software be available for free without having to pay for it? So initially, perhaps it was people enjoy computer programming, they just write programs for free as a hobby code. Early developers have strong ideas about freedom, but actually, open source software has been so successful that now they're using its good, reliable products, and particularly many software tools are actually open source software in that they're available for free, and the code for it is available for anyone to use. In some cases, it was code initially produced for personal use that was spread away because it found to be very effective. Strategies. So you might say, well, if it's open source, how can a business make money if the software is provided for free? But actually, it can be used as a business strategy because obviously a simple example is that whereas the code is provided for free, assistance with using installing it, training on it, and that's what's provided for costs, and the business company does that. And the business Red Hat, for example, makes a lot of profit from doing that sort of thing. It provides just basic free code. The code provided is free, but it makes its profit from assisting with making use of that code. And for this, I'm going to provide you some links to more information on these things. You can look at it if you're interested in seeing more about it. It's not essential to look at these links. Okay, open source software development methodology. So the point here is open source software where we've got so far what we've seen with software development is teams of programmers working closely together as the programmers. Now, open source software doesn't work like this. It's where volunteers, perhaps across the world, are producing the software. So in that case, we can't have, well, rather like we're having now with the coronavirus, we can't have face-to-face interaction. It's a much more larger team across the world, large-scale system. Okay. So one of the pioneers I'm giving Eric Raymond was one of the pioneers of the idea of open source software, and he wrote some things about it. He called it cathedral and bazaar. So what he meant by that is the cathedral is one big building, and the bazaar is lots of little small buildings. I'll give an example. It's actually photographs from Beijing. And the bazaar, I mean, it's really that the best open source software is with lots of different, fairly separate pieces of code, which can be put together separately. That's really what it means by that. So without a strong overall control, a small control overall. So coordinated up a strong overall plan. So there's another thing he said, many eyeballs tame complexity. What this means is another good point for open source software. If the software itself is available for anyone to look at, then any users of it can report the bugs if they find it. So this says it will lead to good safety code because so many users can check it and report the bugs. Large number of users also acting as testers. and can even correct it themselves. Another reason for open source software, business risk. So if you're a company and you need a software product, you could develop your own. That means you'd have to have your own, it's expensive, your own programs to do it. If you purchase closed source code, so it's code where all you get is the machine code version of it, you're then tied to the supplier. You couldn't make any changes to yourself and no one else could change it. So if a supplier causes problems to you, you're stuck with them. Whereas if you're using open source software, then there are several service companies could help adapt it for you. So open source software removes some of the risks that a company's software goes out of business or makes unreasonable charges or changes. It's another good reason for using open source software is business reasons. Software free. It's the strongest form of free software. And this was by Richard Stallman, another very famous programmer who developed these ideas. So what he's saying is that really free software should not only be free, available for free, but should be able to be changed by anyone who wants to change it. For able to pass it on to anyone else to use the changed version if they want. Okay, so Richard Stallman also developed. He likes to call the GNU Linux because he actually developed most of it, rather than Linus Torvalds, just part of it. So GNU is him basically. He knows his personal freedoms, such as in free software, which has all these freedoms, and open source software, which may just have more limited freedom to it. So just say copyright and copyleft. So copyright is the way in which the producer of something controls it, and the usual value of copyright is the producer of something controls it, and therefore enables them to make a profit by selling it, and means illegal for anyone else. Copyleft uses copyright rules, but for the opposite reason. Okay, so suggested by Richard Stallman that use copyleft to force anyone that takes the code to be able to, if they change the code, they must also make it free for everyone to use by use of a software license, which forces it to be free. It's using the copyright legislation, but actually the opposite way which it would normally be used. So it's criticism between open software and free software. We'll go through quickly this idea of e-voting. Okay, this was an example of open source software. So what this is computer programs for elections. Okay, so use a machine for elections, often used in many countries now. The question is, how can you be sure that the software for collecting the votes works properly, or does it do something unfair underneath? With an open source software, you might say you can then look at the software to check how it actually works. It really does provide all the things that it should provide here. Security and accuracy requirements. And this came about, the Diebold voting machine controversy. This is used in the United States, where the software for elections was provided by a company called Diebold, and it was not open software. And someone once found out the actual code used for it, and they found lots of problems with it. Many ways in which security could be broken, and there's a report written by that. So it was an example of why open source software is important, because it would resolve the problems given here. So the Rubin report says here all the problems that was discovered in that code because it was not open source software. So in Australia, for that reason, also introduced computer elections, but they did it with open source software. So the open source software was produced and checked to say, is this software which is working correctly? And errors were found and corrected in that way. Richard Stallman he still says, I don't agree with this for elections, because he still says, how can you be sure that the actual code uses the real one that was given? Core community. So this is saying in large open source software, although it's in a sense don't know whether anyone can be involved in producing software. In general, there's a small core of people who are the active controllers of it, a larger group of people having some involvement in it. And it's particularly applied to a lot of things like computer tools. So the governance of software is given here, so details of how it can be organized. So Android is in a sense open source in that the code is available. This is how it's organized, and actually it's quite limited. So there's still a lot of control by Google on the actual source. Although anyone can contribute to it, the control of it is still quite, so it's quite, in a sense, quite limited free software. So this is just a summary of a general idea what open source software means. Okay. So I've gone through quickly on these others. Do look for this, because it's very important aspects on open source software are given here. Okay, so now I want to move on to the final lecture. Okay, well, although this is the final lecture of new material for this module, there are also some additional lectures last part of video 34, which go through those previous question examples on design principles and design patterns. This is the last actual lecture on new material, tools and best practice. So really just sort of summarizing some of the aspects of software engineering, and going in detail on how Microsoft does it, and also giving some tools for engineering. Let's look at this. Software best practice and software development tools. Again, software craftsmanship and clean code. Again, Robert C. Martin, another very famous programmer whose books are considered very important ones about the idea of good quality code. Another thing he said, as a programmer, you might want to say no to what you're asked to do. Well, why would you do that? Because it may be that what you're asked to do would work. As an expert, you would know that. As a professional, you might say that. So an interesting point about sort of general idea of management here. Learn from mistakes. You learn from mistakes. So it takes time, experience to learn properly. Okay, so looking at this, this is actually what the rest of this is actually originated from someone from Microsoft explaining how they produced all the things that Microsoft produced. Revision control systems and daily build, using it each day, debugging it, and so on. I just go very quickly through this because we've not got much time left for this tutorial. Keep a record of the changes that are made, and there are usually systems which can do this for you. In order to go, if you decide to reverse a change, you can go back to it. So there's programmers, lots of programmers working on it. So check out and check in. Check out is when a developer obtains current version of a file to a particular file part of the program to be able to local to work on it. Check in when it's put back into the main code for the whole system. And what we say, a daily build means that at the end of every day, the overall code is updated to meet any changes that were made. This extreme programming says that every single time something is changed, the whole code should be changed. And what should with every work is a test to make sure whatever change was made has not caused any problems. So all the tests that were done previously should be done every time it's changed. So what we're giving now here are just, we don't need to look at these links, but if you want, you could do 2 tools to help with computer programming. So these are just links to version control tools. These are just tools which store code and previous versions of code if you want to go back to previous versions of code and tools for doing it. And most of these are actually open source software. The search statement is just part of a testing code. So it's something which should be true. If it's not true, it is an error. Unit testing is something you've covered. Unit testing means testing each part of the code to make sure that particular part works correctly. The bug database here is where the errors noted in the whole system, the whole program, are being recorded. So an actual one's been reported and corrected. A program has submitted a correction, but it's not fully correct until the person who originally reported it agrees that it's met what was required for the correction. War team and bug charge. Okay, so what this is again about the management of software. The war team is the senior managers who take control of project engineering. So it's about commercial programming. We're ready for a program which was created to be commercially sold. Perhaps another team, the war team, will come in to check that it really is ready to be sold, check for any errors before and fix any bugs before finally making it available for public use. So code review, just an explanation of source code. Okay, so just to say, if anyone writes code, someone else looks at it to check how good the code is. Extreme programming, pair programming mean that it's continuously code reviewed. Okay, analysis tools for code. So these are tools which are used to analyze code to see how it works. So static analysis tools actually work for not running the code, just for checking the code, checking any errors in it. And debugger is a tool which tests code, assists debugging by running the code, but instead of it runs the code in a way and able to stop it to check what the values of variables are during parts of it. So this is a useful tool for helping you with debugging coding. Again, good rules for debugging code. Particularly as the code gets bigger, it becomes harder to simply debug it. And again, this is there's a link here to a famous programmer who developed this 9 essential rules for good quality programming. Okay, so this is from Microsoft, globalization, localization. So what this is about is a large company which is producing code programs which can be used across the world. In that case, there are aspects of that which need to be dealt with, such as different languages, different formats for dates, and things like that, how it's dealt with in the code. Documentation generators, okay. So as well as the software, an important aspect of software for us to use it, of course, is for documentation for it. Always necessary for code to have good documentation. And in fact, there are systems for automatically producing documents for it, and Java Doc is an example of that. I think you're probably aware of Java Doc. Automatically produces documentation. This is something mentioned by Microsoft, the idea of eat your own dog food. What they mean by that is if you produce something, you should also be a user of it. The case of dog food is a historical example of that. But in general, what they're saying is if you're a producer of a product, but don't use it yourself, that would suggest that you don't really think the product is good quality. So if you produce programs, you should also make use of the program yourself because it says that you do think it's good quality, and also it will help you understand it by making your own use of it. Interactive development are just for tools, in general tools for helping you produce programs. Command line operation. Command line operation is where you're producing code by directly using an editor to choose, rank directly on online rather than using the system. It's also useful to do that as well. I think that summarizes that. Okay, so that's the end of. We've not got much time left, so I'll just quickly mention what else is in here. Okay, so these links here are to code, online code available from somewhere else, which I thought might be useful to look at. So this is just someone else's website on design patterns and other aspects of it. You don't have to look at this, but it might help to see how someone else describes it. That's why it's design patterns and other aspects of coding. And this one here, again, this is some slides on design patterns produced by someone else, which you might find interesting to look at as another way of looking at design patterns. Okay, so as well as that, here's all the code. You can actually look at the code and download the code yourself that's been given previously. I gave in the code on design patterns. Code exercises. These are actual examples. This is code to here we are, decorator, immutable view, composite. It's asking you to actually write code which meets with design patterns, and there are answers now given to these. But do try doing it first yourself. It's a good way to understand aspects of coding, but actually experiment doing it yourself. And similarly with design pattern exercise 2, is using various rules of comparator to sort a list of bank account objects in different ways. So sort by their account number, or by their balance, or by their account name. Different sorts in different ways depending on the comparator object passed to the sort. So these are written examples of okay, connection's gone anyway. Okay. Okay, looks like the connect. Okay, so the connection's gone to the yeah. Sharing applications. Okay, so as written examples of design examples from previous questions, previous exams, which go through them, and now there are solutions to them as well. Okay, so we've reached the end. Okay, so thanks everyone for turning. This should be recorded, but I will now finish this. So we now close the session.